Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Sorry, I'm gonna get the chat working here. Apologies for the delay. What's up, Anch? Sorry, I can't unmute since I'm outside right now. I noticed that Math 32B is a co-requisite for this class. I haven't taken Math 32B. Would it be okay to still take the class right now? Yes. I will say, the amount of, like, Math 32B that you actually need for this class is not that much. And you can kind of learn it on the fly. So I would say, like, you let me know if you can hear me, sorry. Let me chat, actually, sorry. Because I realized you asked a question in chat. Oh, good. All right, you already know. Okay, awesome. Good. But, yeah, this is the exact purpose of office hours. Yeah, if you have a question like that, for sure. If there's any, like, 32B stuff that's tricky, please, yeah, feel free to come to office hours. I'll explain what parts of 32B you need. It's really just like some integration stuff. There's like some surface integrals. But it's easy integrals. It's knowing what the power rule is for integrals, which is just like raise the exponent, divide by the new exponent. And then sometimes like logarithms do show up, I guess. But yeah, nothing too crazy that you can't teach yourself. You'll be fine. Cool. All right. Yes, very welcome. Okay. Let me make sure. Why is my chat not working? Bruh. Bum, 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 bum. There we go. Awesome. Okay. Apologize. I literally got home like 10 minutes ago and I was like, uh-oh. I haven't eaten anything all day. So I made myself a little peanut butter tortilla. Also, my mouse is blinking red. Uh-oh. I might need to go get a battery for this. Yeah, because this is going to stop working. Okay. Can you y'all hold for like, I don't know, like 5 minutes maybe? Well, 2 minutes. 2 minutes. Let me just go grab another battery for this thing, because otherwise we won't be able to stream. Okay, I'll be right back. There we go. Battery's happy. Now it's green. Where's my stuff? But okay, cool. What's up, Paul? How's it going, dog? People are showing up to office hours now. I knew this would happen. I knew this would happen later towards the course. Can you hear me, Paul? I can see you. I can. What's up, dude?
Great, thanks. All right, coming in through my speakers instead of my headphones. Okay.
Audio is always the hardest thing to figure out on any of these
I know,
systems.
it's crazy.
I tell you, bro.
Okay. I was trying to find out. I put it into the. I'm looking at my screen. And
You're okay. It's all good. It's all good.
Yeah.
We don't have to make eye contact. It's fine, dude.
Okay. It was like, what is he doing? I was seeing if there was like a listing of everything that's going to be for the next 6 weeks and when we need to turn them in. I could not.
Let me help.
Said something.
I'll help you figure it out. Let me pull up my portal. Where is it? You have access to Canvas, obviously, I guess, right? The whole Brew and Learn thing?
Yes, I'm in there actually right now.
Perfect.
I'm
okay.
in the syllabus.
Cybersecurity, dude. I hate UCLA, dude. What's this cybersecurity training I gotta do now, man? This is also not the right screen, dude. Excuse me. One sec.
Yeah.
One sec. OBS pulled the wrong web browser. There we go. Cool. Okay. Yeah. So within here, if you scroll down, this is kind of like a table here. And so the only things that are really due, it's either pre-lecture questions, homework questions, and then every day we have lecture, we have like in-class clicker questions. So when they're due is for each thing. So on the left column here, this is pre-lecture questions. And then, so fluid mechanics, the pre-lectures for that is then due the Tuesday of this week, of week 1. And then periodic motion is due the Friday of this week. You probably don't have access to the periodic motion pre-lecture questions yet because those will go live like at midnight tonight. So basically, once we start a new chapter, which we're going to start a new chapter tomorrow, that's when you get access to do the pre-lecture questions. And then those are due the next day at 2 o'clock.
Okay.
Okay.
That makes sense because you go into Kudu.
Yeah.
And you're able to see the information there. So you go to the.
That should also show it as well. Yeah, no, you're totally right.
Okay.
Let me think. Can I see it from my viewpoint? One sec. Let me see if I can. I can also log into a student account.
Yeah, I'm in Kudu right
Okay,
now.
here you go. So you should see here on the right. Do you see where it says like due soon?
Yes.
That should also be pretty accurate at telling you like what all is due. So I extended the pre-lecture questions to be due until like the 29th, which what is that? Was that a... Well, that's actually a long time. Wait, what day is it?
Okay. Yeah, because today's the 24th.
I guess I extended it to the 20th. Oh, that's the homework. Sorry. The homework is due the 29th. So that's like 23 questions. The pre-lecture is due tomorrow. It would have been due technically yesterday, but I extended it out because it's the first week. People just trying to figure stuff out. So that's due the 25th. And then you can see that the clicker questions from today are due by midnight tonight. Pacific time. Or, yeah, PST.
Okay. See, I have I have fluid mechanics, and lecture 2 clicker.
Correct.
The 24th tonight. Okay. This is what I was looking for.
Perfect.
Yeah, because what I'm going to do is I look at your lecture, then I go through Pearson Plus, and I like their format.
Cool.
And then I just want to make sure I don't get consumed in that and I miss questions. So I just need to know one place I can go look, and then I can divide.
Be like, yeah, what all is due? No, I totally agree.
Yeah.
And over the summer, it's especially like tricky because we move so quickly. Like there are things due like every single day, Whereas
Mhm.
if this was being taught during a regular quarter, it would be like once every 2 or 3 days. It would be a lot easier,
Okay.
but we compress everything, so there's a lot of assignments that like kind of come up.
Yeah. So this helps out a lot because I browsed through Kudo and I totally missed this whole due soon summary. I was
Sure.
like, so, okay. So
Yeah, you can
really
use
get me
Pearson
going.
for the lecture for the content. I don't care what you used in order to learn. Like some people just like learn stuff off YouTube. That's totally great. The only thing is that like Kudu is the platform for us to do the assignments on versus I don't know. There's like mastering physics and like all the other ones, but I hate mastering physics. Terrible.
Okay. So, well, that works for me. I
Cool.
will, now that I have my unorthodox bearing, I'll come back with questions probably next week. I'm just
Totally
trying
cool.
to get my bearing right now.
Yeah.
So,
Yeah, no, and I'm glad you're doing that because, yeah, I'm going to make an announcement today to tell students that, like, hey, you know, I give, like, kind of a free pass on the first week because I get it. Like, coming into this, everything's new. You're like, where's all the stuff? What do I have to do? But after the first week, that's when I kind of start getting, like, strict on, like, no exceptions. You got to figure it out by now, and you got to do stuff. Because I can't tell you how many emails I got yesterday of, like, oh, I missed this deadline. I had no clue it was this time. I don't know, like, my cat had diarrhea or something. I'm like, okay, I don't really care. Like, I get it, bro. There was a lot of things going on. It doesn't matter for this week, but next week I better not hear about your cat eating no nasty Taco Bell or something. Like, I don't care. Get it done.
Yeah, it's all about just trying to get a cadence.
Yes. Yes.
For me, at least. For me. So.
Yeah, getting into like
so
a
this
rhythm,
week-
like a regular schedule.
Yeah. So and once I can have like, okay, look here, I got a day to do this, or I got a couple hours, then I can kind of measure everything. So cool. So,
Perfect.
but hey, love your class.
Thanks, Paul. Appreciate it, dude.
Best physics professor I've run into so far.
That's dope.
Love that, dude.
So I appreciate it. So
Yeah.
thanks again. And I'll leave you for someone else right now, but I'll catch you
All good.
in class.
All right, sounds good. Thanks, Paul. Appreciate it.
Thanks. Bye.
Bye. Wow, we've had 2 students today already figure out how office hours work. Office hours works, which is crazy. But also we have 124 students. So wait, I thought I was only teaching like 100. This whatever this quarter. I'm teaching 120 apparently. Oh no, it's about to be a lot. Bresicle says, make a makeshift battery with a tortilla for your mouse. What is this, like MacGyver type shit?
Oh no.
Bresicles, I loved your commentary during the lecture. You were like, what did you say? Like, I'll Venmo you right now if I can give them, what was it, like a Navier-Stokes question or something? I was cracking up, dude.
Oh no.
Dr. Gold, I missed your exam because my cat ate a dime bag. Can I get an extension?
Oh
Yeah, dude, seriously. But that was nice. He said I'm the best physics teacher, dude. It's only been like 3 lectures, bro. Wow. It's all downhill from here. No. Yeah, it's funny. I was talking to my friend. He was driving back from Tijuana last night, and he had been asking me to go to Tijuana with him this last couple days, and I told him, like, no, bro, like, I have to teach. You know, it's the first couple classes, and he said, oh, wow, like, you have to go into lecture? And I'm like, no, I have to, like, lecture. Like, it's remote. It's online. And he was like, bro, dude, you could do that from a laptop in Tijuana. I'm like, I mean, I could, but it wouldn't be this. Like, I've gotten so accustomed to, like, this whole production system thing that for me to teach from just a laptop would be monumentally shittier and, like, more difficult. So it was kind of funny. He's like, man, dude, you're remote, dude. You can teach from wherever. I said, no, not really. I mean, it's nice I can teach from the comfort of my home right now. You know, I can go grab a battery or get a drink or something. But I do still need this set up. Yeah, if I threw them in the deep end, they might get like a little scared. I liked your comments about like, hey man, it's technically a partial derivative. Yes, you're right. All this stuff is correct. But because it's a first year physics class for undergrads, I just don't want to scare them. If I start saying things like that, they're gonna start getting like worried.
Oh no.
So we try to keep it kind of simple for them. I'm a much bigger fan of talking about the conceptual and real world applications of the physics. The math and the whatever, the technical, you know, which type of derivative it is and blah 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 blah. I'm like, yeah, you can figure that out. Like you can go read a textbook. I even see that. I said that today. Like for the Bernoulli's equation, there is a big formal definition that does like, yeah, dw is equal to du plus dk, and then you can come up with expressions for du and dk and like blah 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 and like cool. But rather than go through that whole derivation, which would take probably like 10-15 minutes, I would rather spend that 5, 10, whatever, 15 minutes going over more applications of Bernoulli's formula, equation, whatever. Because I think that really makes it stick in the students' head. I said, like, you can go through the textbook and just read through the derivation. It's kind of uninspiring, honestly. It's cool, but it's not really going to stick. But let me at least show you, like, why Bernoulli's equation is cool and what's a real-world version for it. Oh, I realized my other camera's not working. Let me fix that. There we go. More difficult is negated by margaritas in Tijuana. Yeah, I do not do well teaching if I've had any margaritas.
Emotional, damn it!
It's like not gonna happen. I'm just not gonna teach. I know myself. But yeah, so today we did some cool stuff. We went through a lot, honestly. This class does ramp up really quickly. So we went over Pascal's principle, which is really cool. Oh, one sec. I gotta reload this. It's bugging on me, dude. There we go. One sec. Hold, please. Okay. There we go. All right, cool. So yeah, like Pascal's principle. This is a really cool thing. If you affect the pressure, if you add pressure anywhere in a liquid, that change in added pressure gets added everywhere else. Like all the molecules are sufficiently close enough to each other that any changes in that pressure is communicated like almost like instantaneously to all the other particles within the liquid. I guess viscosity would probably change this though, right? But then we get into like, you know, compressible fluids. And as I said, I don't really want to deal with compressible fluids in this class. But yeah, so this was cool, Pascal's principle. And then I ended up kind of showing that's how hydraulics work. So I don't know how many of the students have actually seen like a car jack, but I've used these many times. And I think it's like super cool that just using a lever and applying like not that much force can enable you to lift something that's like thousands of pounds. Yeah, this is like, it's one of my favorite concepts about fluids, honestly, is like the hydraulics. I hope I don't get in trouble saying master and slave, but that's what they're called. It's called master cylinder and slave cylinder. Like, I'll show you my receipt. I had to spend $400 getting my clutch master cylinder replaced last week. I can show you the receipt for it. It's definitely called a master cylinder. But this is a very cool concept that I wanted to show. And then, yeah, someone asked about the energy conservation. Sensation. I'm sorry, Massa. I'd be a good cylinder. I love that, dude. Fresco says, I like the math more than the physics to learn it. I do marginally better thinking about things as behavior and evolution of arbitrary quantities rather than some physical thing. I have a very unique opinion about math and physics. Yeah, no, I don't think that's unique. I think, and you would definitely be in line with how most professors, definitely most theory professors teach physics, which is they just love going up there on the board and deriving formulas. They'll just go up there and just start deriving things. And I did do this in, I want to say yesterday's lecture. We did do a derivation for how pressure is linearly dependent on displacement or on like height or whatever. And I think that's like kind of useful. It's cool to show derivations if you can connect them with something physical pretty quickly. Some professors will just go up there and just start deriving things all day long. And I don't know, you lose the students. Students don't really get inspired by derivations. Some do. I mean, I guess you do, breasticles, but you're a very special child. Most students I've worked with, if a professor goes up there and just starts like saying a lot of like derivations and doing math, they kind of just like throw their hands up and they're like, what's the point of this? Like, why are we learning this? So yeah, I tend to think physics is physical, so let's show some physical things. And that's kind of that's the feedback I've gotten on my we'll do like professor reviews on like week 4 or something, and this is always very fun. I love to see what the students say about me. But one like common feedback I get is that they really appreciate that I show like a lot of real world examples to where this comes up. We kind of did this one, right, with the sinking boat, or like the block that's like partially submerged. There's a little bit of math here. It's very easy math. It's not very hard. Just a little bit of basic algebra, honestly. This involved a derivative, you know, scary. What's up, Kiss Killer? Oh, long time, Kiss Killer. What's up, dog? And so this was flow rate. And this, again, I tried to tie this back to the real world example of like when you have a hose and like you put your finger over the end of the hose to like constrict it. What did you send me? X to the Z exhibit? What's this? Oh, we do love exhibit. Yo, dog, I heard you like derivatives, so find the derivative of the derivative of the derivative. So the third derivative, which would be the jerk. If we were talking about like physics stuff, yeah. Third derivative is jerk. So yeah, this is another kind of cool concept. So we did, I guess it's called the continuity concept. And then we did Bernoulli's. I might like go through and just derive this actually. Maybe I'll just do that during lecture or during office hours right now. This would be kind of fun to actually derive where this comes from. And then I wanted to use like an this is the cool application of Bernoulli's, which again, yeah, is if you have a height of liquid, right? And there's a hole down here. Like, what is the what's the how far horizontally does it go out? Yeah. I'm now seeing where this comes from, actually. Oh, I kind of explained this wrong. Oopsies.
Oh no.
I could have explained this one better. I actually understand now where this comes from. Uh-huh. Yeah, they actually have the same rho gy at this point. But I'm talking about the water at the top. Wow. Oh, okay, cool. I kind of messed up this explanation then. It happens. I see how I could have explained this better. And then this one, yeah, then we did like some other Torricelli's law, right? That's where that other question went into. And then this is kind of the wrapping it up. If you have an object and it's between two different liquids, like how far does it rise up and down? Okay, Bretzko says, not that opinion. When I say I have a unique opinion, it's that I think mathematics is entirely physical and it's foundationally built off the science of quantities, so to speak, and how an arbitrary quantity can evolve and behave, and it's job of physical scientists to properly choose the mathematical model for which it evolves, and then it's a job of mathematics to analyze the system. Okay, cool. This is kind of how my grad school career worked. I'm an experimentalist, so I enjoy, taking the screwdriver, mashing things, taking the soldering iron. Yeah, exactly, Sensation. I like hammers. Yeah, exactly. That's we would always joke in grad school, if you want to tell the difference between an experimentalist and a theorist, hand them a screwdriver and ask them to use it. Like, ask them, which way do you turn the screwdriver? And the theorist won't be able to figure it out. but experimentalists know, righty-tighty, lefty-loosey, whatever. So, yeah, throughout grad school, I did a lot with, like, coming up with the tools and techniques and whatever, the data collection methods in order to document the observations, to document the phenomena, I think, which you're talking about, like, yeah, the quantities. And then from that, I would try to see what mathematical model would fit to it, but more so, I would just pass my data and my results to a theorist, and then it was kind of the theorist's job to develop the algorithm, the equations, the whatever, to simulate what was happening, and then to understand what the underlying equations were that were governing this behavior. Yeah, the theorist would tell you it depends on how the screw is threaded, right? It could be reverse threaded. That's true. A lot of things like bicycle pedals are reverse threaded because if they weren't, I think like the motion of a bike, because the motion of a bicycle is counterclockwise, so you would naturally unscrew whatever like from the pedals. Yes, reverse threads. Yeah, exactly. Yeah, there's Master Chief. Reverse threads by the rings, yeah. Let me go find that derivation of Bernoulli's. I kind of want to do it. I kind of do. It was in our diagram here. It was in the textbook. Let me go find it. Boom, 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 dun, 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 dun. Okay, so Bernoulli's equation comes from energy conservation. Okay. Okay, let's get like the diagram. Let's just kind of go through this. It'll be kind of fun. And then if any of the UCLA students like show up while we're here, we'll get a little introduction to it. Okay, so they say consider this type of system of flows, okay? So you have an amount of liquid here, cross-sectional area A1, height or thickness, whatever, dx1, and so that gives you a dv. It's moving at some velocity, and I guess there's a force being applied to it, which, remember that force over area is pressure, so force is equal to pressure times area. And then also this thing is located at a certain height from wherever we measure this. So this is, I think they're calling this like h equals 0. Okay. Automod hates you. You can say whatever. Here at Breasticles, are you not a mod already? You should be a mod in my thing. One second. Let me just make you a mod. There you go. I granted you mod privileges. So now it shouldn't yell at you anymore. A mechie major who's complaining about fluid dynamics. Yeah. Okay. And then let's consider some other chunk of liquid which has a cross-sectional area A2, so it's like thinner here. Some dx2, some v2, and that's going to produce a force on like the opposing side of, I guess this is a closed container, is this what we say? Let me think. And then, yeah, because it's incompressible, we say that the shaded volumes must be equal. So that comes from like Q1 equals Q2. Yeah, there you go. Congrats. All right, yeah, okay. So we can say like because incompressible. Q1 is equal to Q2, so we can say that what is it gonna be? A1 V1 is equal to A2 V2. Yeah, where that's the velocity. And then, interesting. They said the shaded areas are the same. I guess because it has to be the same volume. But wait, they're traveling it. I don't think A1 dx1 equals A2 dx2. Is that true? Or I guess it is, because dx2 refers to the amount of x2 that's traveled in a certain period of time. Okay, I will agree with that. Okay, fine. So I can also say A1 dx1 is equal to A2 dx2. That's okay. Okay, I can consider that. Because V1 is the same thing as dx1 dt, and then V2 is equal to dx2 dt, and this is where like Zach would get super mad at me. But right, watch what I'm gonna do here. I would say like, oh cool, well A1 dx1 dt is equal to A2 dx2 dt, and then we're just gonna cancel the dt's. I'd be like, well, it's the same amount of time. So then this is true. I feel like someone in Mathland would get mad at me for that. Okay. And then we also assume there are no viscous forces in the liquid, so the energy of any part of the fluid will be conserved. To derive Bernoulli's equations, we must calculate the work that was done on the fluid. Yet not just Zach. He says, I'm here. I'm here and I won't let it stand. You're what do they call that? A steward of the standards for math. Okay, let's think about so dW, which is the work. Okay, so dW. Well, first of all here, right? So work is equal to the integral of f dot dx. This is known from mechanics. And so if we take the derivative, the differential of both sides, then you just get dW is equal to f dx. Okay. So then the net work for the entire system, say like dW total, right, is going to be f1 dx1, right? So that's from this, minus f2 dx2. And I think I understand what's happening here. We're going to assume that this was like a boundary, so the force acts perpendicular to it, and then this is a boundary, so the force is acting perpendicular to it there. Okay. Okay, so then solving for this, well, F1 is equal to P1A1 and F2 is equal to P2A2, okay? So by this, so we can say P1, A1, DX1. Would it not be easier to get there from work energy? I think this is kind of work energy though, right? This is work. And then we're going to talk about energy. We're going to get there. And so then this is, so P1A1 DX1, and then that's going to be minus P2A2 DX2. Okay. Uh-huh. Okay. And then what we recognize is that A1 dx1, this is the same thing as dv, like d volume, right? That kind of came from Yeah. This times this is... Surface area times the change in x is the same thing as the change in the volume. Okay. Because V equals A times X. Okay, this is actually just kind of weird. All right, so dW. So then this is the and the dVs are the same, right? We said A1 dx1 equals A2 dx2, and then this is equal to dV. Well, let's make the color here. Oh, nice fit. Yeah, see, if I was doing this during a lecture, dude, this would just take way too much time. And I was already like running out of time trying to cover what we did. This is where they say, like, you know, this is better left for the reader or some shit. But okay. So I can pull out a dV, so then I get P1 minus P2. Cool. And that's work that's being done. Okay. Now also... But also... by work energy. Yeah, right? It is pretty crazy. I kind of like it, honestly. If I had to teach 2 hours, dude, I'd be kind of zonked. You know what I think the sweet spot would be? I think like an hour and a half. I think I could do an hour and a half. Hour 15 is too short. 2 hours, you have to put like a 10-minute intermission then. It's just kind of annoying. Okay, but by work energy, right? Isn't this the same thing? Like change in work is equal to... It's usually just change in kinetic energy though, no, right? Or I think that's like net work. Where does the change in potential come from? Oh, really? He just cuts it. He just cuts it early. Yeah, this is W net's equal to change in kinetic energy. How do we get the potential in there? No, it's change in kinetic. I remember it being change in kinetic energy. Okay, but that also considers the force done by gravity. Hey, Phoebe, what's going on? We're just going through a little derivation of Bernoulli's formula that I didn't have time to go through in class, so I was just kind of like re-deriving it. But if you have any questions about the class, I can totally answer or help out. This is just kind of doing something for fun. Just watching, cool. All right, yeah, cool. Please, yeah, by all means, just watch. Okay. So, just a little recap. We're looking at Bernoulli's formula, Bernoulli's equation, which describes the kind of like the three terms you have to consider, the three like pressure energy terms, and I want to kind of see like where this comes from. The book does a derivation of it, but as I'm finding out, and as I remember from last year, there's just not enough time in an hour and 15-minute lecture to like also derive it. So I think what we're showing here is that work is equal to integral of force times distance. So d work is F dx, and then if you have two chunks of fluid at different places, the force on this side is the pressure there times the area. This one is the pressure times the area. You can plug that in, and then you make some fun little simplifications where you say, oh, well, the area times the change in the distance, that's the same thing as a change in the volume, and that this is also a change in volume. And then because of the flux thing we had, where we said like A1 V1 equals A2 V2, that also means that the dV here, the volumes have to be the same. Okay, so then we get to this. Okay, but by work energy, so yeah, network also takes into account the work done by gravity, and we haven't nice lost. We haven't considered we haven't considered the work done by gravity yet. So I think, yeah, W work total is delta KE plus delta U at this point. Yeah, because we're not considering work done by gravity yet. Okay, I think I can get that. So okay, so then let's figure out like what delta KE would be, right? Oh, well, delta KE. that would be, that's just 1/2 mv squared, right? So we could say like 1/2 m1, I would say like, sorry, let's do m2 v2 squared minus 1/2 m1 v1 squared. And then what is mass? Well, mass is going to be equal to rho, the density, times dv. Yeah, I can say, oh, but mass is equal to rho dv. So here, this turns into 1/2 rho 1, and these are different v's. This is rho 1 dv v2 squared minus 1/2, or this is rho 2, sorry. Minus 1/2 rho 1 dv v1 squared. Yeah, cool. And that's equal to change in kinetic energy. Great. Okay, I think I can simplify some stuff here, right? I see dv in both of these. So I can pull out a 1/2. So let's say 1/2 they have different rows though. Okay, so I'm gonna say 1/2 dv. Oh, I guess we assumed it was the same fluid though. Right? I'm gonna keep it separate though. Because it could change. Maybe. Or maybe not. Let's say rho 2 v2 squared minus rho 1 v1 squared. Yeah, it should be the same rho. Can the density not change? I guess it doesn't really ever, right? Yeah, okay. But rho 1 equals rho 2, like almost usually, right? Okay, so whatever. We'll just call it rho. We'll just pull rho out. Okay, it shouldn't change in order for it to be... Yes, if it's incompressible... You're right, Brasicles, yeah. If it's incompressible, then... Yeah, the density cannot change, because if the density were to go up, then it would have been getting compressed. Okay, so this is equal to delta KE. And then, yeah, the change in potential energy. So this is kinetic. And then potential. This is so delta U. That's just going to be equal to mg delta H. So we can just say that's going to be rho dV, or rho g dV, I guess. Don't like putting things after dV, honestly. Rho g dV, and then that's going to be y2 minus y1. Yeah? Okay, cool. So now let's put it all together. So I'm going to get that dV, P1 minus P2. So all together is equal to KE. Okay, so that's 1/2 rho dV v2 squared minus v1 squared plus rho g dV y2 minus y1. Oh, and this is cool. So now all the dVs cancel. And we're left with P1 minus P2 is equal to 1/2 rho v2 squared minus 1/2 rho v1 squared plus rho g y2 minus rho g y1. And now you can move all the 1 terms over and move all the 2 terms over. Okay, and this is where you get P1 plus 1/2 rho v1 squared plus rho g y1 is equal to P2 plus 1/2 rho v2 squared plus rho g y2. Cool. There we go. Yeah, and that is That's Bernoulli's. That's literally Bernoulli's equation. Very fun. Okay, and I want to explain like where I think I messed up explaining this one specifically, right? So I defined this height as being equal to 0. And what I did was, okay, so I said, okay, so P1 is P atmospheric, this is this. And then for this, I said, oh, well, this is equal to the amount of fluid which is above it. It's technically wrong, the way I explained that. In fact, this is also still 0. If we're considering the water here and the water here, and they're both at the height h equals 0, this will equal 0. What will change is that this P1 will no longer be just P atmospheric. It's also going to be the pressure from the fluid above. And that right there is rho g big H minus little h. So this term actually came from this. Yeah. Legendary Pro. Yeah. I see where I messed up on this, explaining it. I just kind of said this and I was like, oh yeah, it's just the amount of fluid. Well, I didn't mess up. Like, it is true, but I attributed it to this without really explaining that these terms are both equal to 0. The other way to do this is to consider the water here as like situation 1 and the water here is situation 2. And then in that case, this would end up being rho g H minus big H, and that would come from here. And then P1 would just be the atmospheric pressure. That's also valid. So I see there's a bunch of ways you could do it. Always improvements for next time. Anyways. Cool. Well, it's been about 55 minutes. So here, let's start up Discord. We'll help out some students on our regular channels. Just give me a second. Make sure that works. Yep. Bum, 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 bum. Office hours. There we go. Okay, so we're live back on Discord if you guys want to come on Discord. And then let me start us on TikTok. Open the floodgates. What's the ticker shout out? What do you want? 55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 100. Yeah. Dude, this is such a good... Dude, you know where this meme is from? It's from... Oh, man. What is it? I love this guy. Oh, man. I really think you should go. I really think you should go. Or I really think you should leave. It's such a good one. Such a good meme. No, I saw it on someone messing with an AI drive-thru. Oh man, no, I think it comes from this. One sec. It's the taters. Yeah. This is it. Okay, so his name is Tim Robinson. He's a hilarious.
You know, I'd like.
He's like he like goes up to the drive-thru. He says, "You know what?
Guys,
I'd like to pay for the guy's meal behind me, too. You know,
just pay
like,
it forward.
just pay it forward."
Wow, that's really nice of you.
Yeah, who knows? Maybe it'll catch on.
He's like, "Who knows? Maybe it'll catch on." This is the thing that like happens in ideal worlds, where someone starts a pay it forward chain, where like the guy at the drive-thru, he'll pay for the person's meal behind him, and then that person will pay for the meal behind them.
All right, well, you have a great day, sir.
But then he's like, all right, but wait a minute, I gotta rush around.
Stop! Please let me go! Please let me
This guy is sensational in just being ridiculous. I love
go
him. He's so
first! I'm
good.
doing something!
So he goes right behind.
Hi, can I take your order?
55 burgers, 55 fries, 55 tacos,
This is the meme where it comes from Sensation.
55 pies, 55 cokes, 100 tater tots, 100 pizzas, 100 tenders, 100 meatballs, 100 coffees, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So he orders a ton of food, hoping that the guy in front of him, who he paid it forward for, will end up paying it forward for him, like
Okay,
behind
that'll
him.
be $680.
Okay.
Yeah, it's a great comedic short. It's a bunch of little comedic shorts, and that guy Tim Robinson, he's legendary on some of them. Yeah, it's funny. I love it. Okay, let's see. What do we got on the queue? Oh man, I need to go to the gym. I need to pack. Yeah, wait. Did I get my Let's run on my stream. One sec. I need to make sure I get my boarding pass for tomorrow. Don Rickles. Oh man, do I know who Don Rickles is? I'll have to remember. One sec. Where's my boarding pass? One sec, let me just make sure I get this. Excuse me. Oh, I gotta log in again. Check in. Southwest used to have it where you had to do it exactly the hour beforehand in order to get like the prime seating. They've changed it since though. Now you have to like pay for your seats, which is like what? I loved Southwest because you always got to kind of, what was it? You used to gamble with who am I going to get as my seat partner, and you could kind of get to choose. Okay, cool. I board at 105. That's good. And this is also why we're gonna stream lecture early tomorrow, because lecture here will end at 11:45. I'm hoping to get down to LAX by 12:15, and then I gotta somehow get to my gate by like 1. It'll be okay. Okay. Let's see. What do we got on the queue? What is? I think Work Theorem guy has submitted some fun ones. And there is breasticles there as well. Nice. So this one, and then this one. You know what I'll do? I will agree to doing one hello question per stream, and we'll have the spinning wheel determine like which one it is.
Let's go gambling!
Unless breasticles magically got chosen, that would be hilarious. Okay, cool. So it's a combinatorics question. Okay, here we go. Oh, okay. Blessed combinatorics. Am I watching the World Cup? I did. I was getting my haircut today. And I was watching Scotland versus, who was it? Brazil. What did that game end up being? I saw it was 3-0. Poor Scotland. Oh, it stayed at 3-0. Okay, good. Not too bad. Yeah, they ended up taking one of the goals away from Vinicius. He had another one, but he fouled the guy on the way in. He would have gotten a hat trick. Who's your GOAT? I mean, Messi's the GOAT, obviously. What? I've seen like some really fun graphs about like statistics and standard deviations. And dude, Messi is like 6 standard deviations away from like first of all, like the whole World Cup league, which is already like really elite people. He's like a freak of nature, Messi, apparently. Okay, consider 4 boxes where each box contains 3 red balls and 2 blue balls. Pause.
Nice.
Assume that all 20 balls are distinct. In how many different ways can 10 balls be chosen from 4 of these boxes so that from each box at least 1 red ball and 1 blue ball are chosen? I feel like this is the inverse thing where you want to figure out the probability that a red ball and a blue ball are not chosen, right? And you do like 1 minus. Whenever we say like at least 1, it's like 1 minus the probability that there are none chosen. It's usually how this works. Right. So yeah, probability of at least 1 is equal to 1 minus the probability of none. This is a very like useful thing that comes up in probability. Usa, who's your goat? Okay. So we got 3 reds and two blue balls. And there are 4 of them, right? So 1, 2, 3, 4. And we have to use 10, and we have to pick 10. Okay. So I guess what I want to think about, like, how can we choose no red balls? Plus, how can we choose no blue balls? And I guess technically there's a probability that you could pick no balls from any of the boxes, right? Ah, but wait, if you pick no balls from the other boxes, then you're going to have to pick at least 1 and 1 red. At least 1 red and 1 blue. Oh, wait. And how many different ways can 10 balls be chosen from these 4 boxes so that from each box at least 1 red ball and 1 blue ball are chosen? Okay. But if you only choose balls from here, then you fail as well. Right? Yeah, okay. So, I would say this, right? Rather than figure out all the ways that you could succeed, if you number the balls 1 through 20, it might be easier. Okay, let's try to do that, Jeff. I kind of like that. So what are you saying, Jeff? If I do like 1, 2, 3, and then 4, 5 from like this tranche, and then you have like 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15. And then 16, 17, 18, 19, 20. There is sensation. I can always hear your breathing on the mic, dude. He's
Sorry.
always watching. He's always watching.
It's because it's so hot.
Yeah, do you guys got a heat wave over there? How bad is it?
31 Celsius.
Ew. Okay, let me see what that is in freedom units.
And everyone's like, "Oh, it's fine." No. Again, I've said this every time there's a heat wave.
Yeah, your houses are not designed
specifically to
keep heat in.
To keep heat in.
Yeah. I saw Paris was hitting like 100. What's up, Breskles?
I'm
There you
also in a heat wave, kind of. In other words, my AC went out, and it's about 87 degrees inside of my apartment.
You and Sensation both, then?
Yeah, it's not fun.
Not fun. Damn, dude. Didn't you just move into a new place, dude?
Yeah, I have really like shitty luck with
Apparently, that and like
ACs.
cars.
I moved it. Yeah, but the ACs I have a higher kill rate, I guess, so to speak.
Oh my God, it's
I've
100 and
killed 3 ACs in 3 apartments.
dude, it's 104 degrees in Paris, dude.
Emotional, damn it!
Dude, that's so bad. Because like, dude, Europe does not understand what air conditioning is. They just don't have it.
It's also unnecessary.
Correct. Until today, it's very
If
much
you build your
necessary today.
no, it's unnecessary regardless. If you build your houses correctly, you don't need air conditioning.
That's nuts, dude. It's gonna go from 104 down to 80 in like the course of a week. That's crazy.
To be fair to the architects in making English houses, though, usually the houses don't see the sun, so they don't get much thermal energy.
Right, yeah. That is true.
And that's because we're laterally parallel with like Ottawa.
Iceland. Yeah. Or like,
Oh,
I think it's like Nova Scotia.
yeah. No, I think we're higher.
Or
than
it's
that.
because England is just like a real life version, at least physically, of 1984. Like,
Wow.
if I had to imagine like what it looked like reading the book, I kind of just imagine England.
You are aware of the irony of that statement, right?
I'm
what's
just
the irony?
talking like how it looks, and
What's the irony?
There
of
is
it?
objectively
walk
less
around.
freedom in the US than there is over here.
You
I'm
guys
not
don't have
talking
a-
about freedom. I just mean like
Yeah, they don't have a Bill of Rights,
cloudy,
dude. They don't have a Bill of Rights. man.
miserable, like cold weather.
It's not cold though.
It's not cold.
Temperate.
It's
It's
damp.
temperate zone.
It's
It's
damp.
damp.
I live in South Texas. That's cold. It
Yeah.
gets to 75 and we put on hoodies.
Yeah, we're just like, it's way too cold, man.
Never go to Scotland then, you'd die.
I think the Scots are going back home though, dude. Unfortunately, I think with soccer today. Not that Sensation cares about soccer because it's a gay sport, but okay.
I mean, it is a bunch of dudes playing with balls.
Yeah, he is correct there. He's not wrong.
You may take me, but you can never take my bunghole.
Oh man, dude. Yes. Wow. Wow, dude. Weren't they remaking Beavis and Butthead? Or they
I
brought
think
them into
they-
Call of Duty at least.
I think that they made some more, but they were like old guys.
Mm.
And then instead of Cornholio, he was oh shit, like forgotten. Old Holio. That was.
Old Holio. That's a funny one.
And he's just like on his mobility scooter and.
All right, let's think. This shouldn't be too hard, right? So, probability of pulling one red and
Well,
one blue
we
ball from
shouldn't-
each one is
I
one
don't
minus the
think
probability
we
of
should
failing.
be doing the probability because it's asking how many ways.
Oh.
What's the probability that we do it? So we want to use
Oh shit, dude.
permutations and combinations.
Emotional, damn it!
Oh, I thought it was a probability.
Get there.
Okay, I get it. It's how many ways. Which could be the total number of ways minus the ways that fail, right? I mean, you just multiply this by like
Actually,
the total
yeah.
number of ways, right? You just multiply by the total number of ways of 20 choose 10.
It's been a minute. It's been a
I think
minute.
so.
So possibly.
If you were choosing 8 balls, it would be 5 choose 2 to the 4th power. I was choosing 8 balls. Why is it 5 choose 2? Or is it not 4 choose 2? Because there's 4 bins. Where'd the 5 come from, Jeff? Jeff?
My name is Jeff.
Is it 4 choose 2?
You know what's really weird? I've just started going through the logs just to make sure everything's up to date. And
Yeah, what's up?
who signs up to Twitch under the name Stuart Miller's Solicitors?
Yeah, the solicitors is... Yeah, it's a little suspectual, dude. 3 to the 2 to the 4th. Okay.
See, with a name like that, I reckon Nigerian, not Bangladeshi.
Do you think it'd be that dumb to like say that you're solicitors?
Of course they are. Are you kidding? The average IQ in that part of the world's 80.
Yeah, it is room temperature. Yeah, room temperature IQ, literally.
Or was it? It's 60. It was something stupidly low anyway. That being said, I think 100 is stupidly low. That's the average in the West. So.
100 is pretty decent, dude. I would be happy talking to someone from 100. I feel like a lot of times I'm dealing with people that are under 90. I don't know.
No, but I think 100's usually the baseline.
Is it? Is that why it's 100?
Yeah, 100 is like the baseline average.
Do you think it changes?
IQ.
Does it change over time? Like, has baseline IQ? It's definitely decreasing.
I'm not sure. They've like recently kind of stopped like just doing IQ tests in general.
I've never taken one. Have you taken one?
There's the fall of society. Right there.
Like taking them, but they're not really like. Hey, most of them I'm not going to spend money on it because they don't tell you what the IQ test entails, and they don't give you any certification.
There is like Mensa, right? That's a thing, right? Mensa. Mensa's like a real one.
Say like a lot of them are just like, oh, what's the next thing in the pattern? It's just like a grid of shapes,
it's all pattern recognition,
which is just kind of. I don't think that 20 questions of what should just be elementary school like pattern stuff is really.
They call it like the Ravens. I think it's called the Ravens test. Have you heard of this before? The Ravens test. I know my friend uses it for like neuroscience. Yeah, the Ravens progressive matrices is a nonverbal assessment measuring fluid intelligence, abstract reasoning, and pattern recognition. It's kind of like one of the standards they use for like cognitive assessments in like neuroscience. Yeah. Oh. Okay. Can we do like a standard, like let's do a test one. I'm just curious because I don't want to figure out the balls question, honestly. Let's do a Ravens test. I'm really curious actually. Practice Ravens test. I just want to see. Mensa. Okay. Is this gonna be some bullshit where I'm gonna have to pay for it though? That's always like, it's online IQ test.
Free to take the test probably means at the end they're gonna be like, okay, you want to get your results?
That's so bad. All right, here let's ask ChatGPT. Let's say like, hey chat, sorry, where is it? Oh, there you go. Be like, where can I take a totally free Ravens test and get my score without paying or signing up for anything? Just go find it for me.
That's your local psychiatric facility.
Oh, that's probably true, actually. We don't have those, though, in Los Angeles. Just have, like, catch and release.
No, yeah, they're all out on the streets, same with here, which is why the entire place is falling apart.
Okay, here we go. It's not officially Ravens, but it's very similar. Visual Matrix, 35 questions, 25 minutes. No payment, no sign-up wall. Okay. Apparently. Should we trust this?
Jack gave us it, so hopefully.
Okay. Please select your age range. Dude, this is wild. 16 to 17, 18 to 50, 51 to 60, 61 plus. Okay, so we get 25 minutes. We got 25 minutes left. Let's fucking do it. All right, here we go. Okay, let's see. So in this example, you can see a grid of 9 boxes, one of which is empty. You must choose which of the 6 alternative shapes must be placed in the empty box to complete the pattern that connects the shapes. As you can see, all the shapes are black. Each one contains the same shape. So the correct answer is B. Okay. So we're going to have to like recognize patterns here for whatever ones. Maybe
I just don't see how that like.
You don't see why this measures intelligence?
Like, I see how to a degree it could, but giving like 35 questions of this type and then being like,
they get progressively harder though, dude.
120. Yeah, but there's only so many ways that you can make a pattern of shapes in a 3x3 that difficult.
Let's see. Here, let's take it. Let's figure out the group collective collective
Maybe I'll
IQ.
use my words.
Yeah, let's find out the collective IQ of this live stream right now. So if you guys want to suggest answers while I'm doing it, I will try to say what I think is right. But if I'm unsure, like, yeah, let's figure it out. Fuck it, let's do it. Okay, let's try to figure this one out. Oh, I feel like this one is most definitely A. Oh man, it doesn't let you show what we did. Okay, there we go. So yeah, I think this one's pretty simple. I'm gonna go with A. Circles. So okay, circle, 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 plus, plus, plus,
Should be E.
diamond, diamond. I think it's E.
Yeah, I think so.
I think so. What's the difference between E and B though?
Because it's a
Oh, because it still needs to be a square. Good.
tilted square, yeah.
Yeah. Okay. Good. All right. Circle, circle, diamond, diamond. Okay. So we eliminate choice D and E. Let's see. So circle. Okay. So circle plus.
I think it's F.
I think it's yes, because I think it's blank, right? Because there's
Yeah.
one of each one.
Yeah, it's whichever one's not there.
Okay. I want to say this one is down. I want to say this one is
Yeah, it
F.
Should be down. Should be F.
Should be F, right?
Yeah.
Yeah. Yes. Okay, cool. All right, let's see this one. Okay, so the arrow is moving. Okay, so this needs to be to the right, and the arrow needs to be on the left. I think it's D.
Yeah.
Okay. All right, we're getting good, guys. This looks like Tetris. So, let me see the shape. I think it should have 4 and then 3. Oh, but it can't. Oh, is there a spillover then? Oh man.
I think it's E.
Yeah, you think it fills is what it does?
Yeah,
Because I
it
see
looks
like 1 1 1 1 2 3 2 2 2 1 2 3. Oh, this should be 3 3 3 1 2 3.
Yeah.
Yeah, that's E. Got it. All right, cool. Oh man. Okay. These are the diagonals are the same. But how does this one relate then? Oh fuck. Oh no. Oh, see, now it's getting tough. Oh man. Yeah, I guess I try to think about like processes, but it's like rows and columns. I'm pretty sure. I don't know if we count diagonals, but the diagonals are all the same here, which is nice. But then how do I do this? Okay.
I think it's E. Because
What-
in essence, what you're doing is you're, or at least what it looks like, right, is every time when you start at a corner, you move
Yeah.
your initial square over to the
To the right.
clockwise corner, and then you add one in the pattern. So in this case, on
Oh, okay.
on the
Okay,
bottom
beautiful.
one, you
Yeah,
move
I didn't see that.
square clockwise, add one to the pattern, and then the next time you'll move it clockwise again and add one to the pattern.
I agree.
which is
I agree. Wow, that's good. See, I didn't see that. I didn't see that one. You saw that. That's cool. Okay. Yeah, they are getting much harder now. My IQ's already shot. Oh man. Okay. They come together, maybe? No. Okay, the second one. Okay, the second and the third column are vertical flips of each other. So
Yeah,
this
I
one,
wanna
I
say
think,
it's
I'd say it's C. Yeah, I don't know how it connected to A, but okay. Okay. I'm gonna try to take the breasticles method of here of like there's a like this box is moving around clockwise, right? Okay, so then the box should be on the left, the dot should be on the right. I think it's F. No. D. Yes, I agree with D. Okie dokes. Oh, everything's just rotating counterclockwise. Duh.
Yeah.
Okay. This is easy, dude. This is D.
Should be no C. Oh no, D. Yeah.
Yeah, it would be D. Ah. Okay, that's my point.
No. To be fair, it was because I thought it was on the left. I think I'm
okay.
slightly, like,
Okay,
graphically
big
dyslexic.
dog. All right, let's see. All right, circle. The square goes around the circle. The circle disappears. The circle Another circle and a square. Oh, I'm trying to see if there's like some like round robin thing here that's happening. You know what I'm saying? I'm trying to like apply like some logic rules. Like there's some like circular thing. We're only a third of the way through, but we're almost a third of the. Okay. Circle, square, thing goes away. Circle. Oh, okay. Wait a minute.
Because you're
Okay,
adding a shape to the original shape,
yes,
and
yeah.
then
The new thing
original
added
shape
disappears. The new thing added disappears. Is that kind of what we're saying?
or
both things disappear.
Disappears.
The original thing
So
disappears.
you're adding a shape on top of the original shape, and then
Yes.
removing the original shape.
Correct.
On the right.
Got
So
it.
A would
Yes.
be the correct one, as you add the oval and
And then
get
you
rid
and then
of
you
the
subtract. Yeah, exactly. Okay, very cool. All right, I agree with that. Oh man. Okay. Okay, it's rotating clockwise, but
Yeah, blacks,
anytime.
and then you rotate clockwise
Yeah,
every time.
but
so you gotta
but
make sure the last one's black.
I think you're rotating clockwise, but anytime one of the bottom corners is black, then it's gray. No, because then
No, I
this
think
one
it's
should have
just
been
that
gray.
there's two blacks in every
Interesting.
row,
Okay.
and then you rotate clockwise, so it would be what's it called?
It has to be black as well. So this would be A, right? A?
A, yeah.
Okay, cool. Okay, circle, diamond. Okay, so there's always a black one and a gray one and a whatever. So it's either B or C. So this one is B.
Yeah.
Easy. Okay. There's always a diagonal, a horizontal, and a vertical. So there needs to be a horizontal here. So it's either A, B, or F. And then it's the missing shape, which is A. Yeah.
Yeah.
Cool. Okay. 1, 3, 2, 3, 2, 1, 2, 1, 3. And then is it up, right, down? No, because this one has a left. Oh, but we're going
It's
clockwise.
rotating clockwise.
Good. Yeah. Okay. So this one's up
It would
with
be
3.
F.
F. Yeah. Good. This is kind of shitty, dude. It's just rotation. Is that all we're really like testing here, dog?
Pretty much, yeah.
Okay.
Rotating clockwise, changing.
So
pattern,
top right
color,
and
it's
so
gonna
B.
go- yeah.
B. Okay, cool. Okay. Okay. Interesting.
Literally just rotating clockwise, so B again.
But okay, but here's the weird thing. From this column to this column, it skips the 6 o'clock. See how we go 1, 3, 4, like this. Oh, this is like 1 o'clock, 2 o'clock, 4 o'clock. This is 3 o'clock, 4 o'clock, 6 o'clock. Oh,
Yeah, so it goes
oh.
1 and then 2.
So it goes
yes.
1 and then it goes 2. So this is 5 o'clock, 6 o'clock, 8 o'clock is what I need. Oh, which, yeah, has to be B. Oh. Okay, cool. All right, equals, dash. Okay. Oh, man. I think we added T to each one. Like we're adding a T to this. I'm adding a T to, but that's gonna look kind of weird. Wait, why is it? Oh no. I want to say it's C. Yeah.
Yeah, C seems like the only one. that
I think
makes
I'm going to
sense.
say it's C. It's kind of a harder one. Okay. Square and diamond and circly thing and plus. Okay, I think we just have to have all 3 shapes. So we have the plus, we have the circle, we don't have the dots. So I need the dots, and I also need the diamond. So I think I need A.
Yeah, I think so.
Okay. UZN. I feel like it's a rotation game again, but we add, and we like, we're subtracting one of the lines. No. This one's hard, man.
Oh, I see what's happening. It's basically we're doing like the intersection of it, so to speak. Whatever we're getting rid of the intersection. So whatever.
Whatever
shape
overlaps.
has- yeah, whatever overlaps, we get rid of.
That's cool, dude. I see. Very cool. Okay, all right. So then we would remove the middle one, and it would just be...
A.
Yes, correct. Wow, cool. I didn't see that. Okay, this is just adding shapes to each other, I guess. Or is it subtract? No, this one's adding. Oh, but you subtract anything that overlaps. Okay, got it. Okay. So, I think it's going to be B.
Yeah, I think so.
Okay. All right, we're almost 2/3 of the way through. Okay. Oh, this does like hurt my brain, dude. I'm like tired. Okay, the bottom always stays the same. The top goes from square circle to square to circle square. So E? Yeah.
I think so.
I think so as well. Okay. Oh, these are fun. This looks like a brand of some sorts. Okay. Swap, make the middle. No, that's not gonna help.
Each 2 out of the 3 squares both have 2 black, and then one has 1 black, 2 white, and then 1 square would have 2 triangles and a circle, and 2 squares would have square, triangle, circle. And then so we would need to find whichever one would be unique with the square, triangle, and a circle.
I see. I think I see. Well, 1 sec. Because I'm seeing the first row and the last row are almost like mirror images of each other, kind of. Or not really. No. I'm like seeing this and this are a mirror image, but no. Okay. No, but yeah, in the middle column, I was like, maybe it sandwiches something. No. No.
Oh, everything's moving left. So,
But then it's also alternating colors? Wait. No. Let me see. 3 triangles, 3 triangles, 3 triangles. And it was 3 white triangles. 3 black circles, 3 black circles, 2 black circles. Okay, so we need a black circle on this last one at least. That's only eliminates choice C. And then in terms of squares, it's black, white, black, white, black, so white. Okay, so I need a white box and a black circle. Okay, so that's either choice B or choice F. Oh man. This is a toss-up for me between B or F.
I think it's F.
I think it's F. Yeah, you need a black
Yeah, if
triangle.
you look
I agree
at-
too.
Well,
Yeah.
so if you look at how the circles are moving,
Yes.
right on the left one, it moves one to the right, and then on the one right below it, if you look at the top left, it's in the center, and then the one
Yes.
right below it, it moves.
Oh, I
one
see.
to the
Center,
and then
right,
the next
left.
time it moves
Left, center, right.
back to the first position, and so on and so forth.
Got you. I agree with that. Cool. Yeah. All right. Good. What's up, Todd? Yeah, we're doing a Mensa IQ test. Okay. Okay.
No, it's another.
Oh,
like-
it's the reverse. It's the reverse subtractions, but it's from right to left, right? So
No, about right. I just mean like if you look at the top line,
yeah.
the horizontal on the left
Mm-hmm.
disappears, and then you get the K-looking shape. And then if you look at the second line, the X's would overlap. So the
Good. Yeah. Okay. I get you.
X would
Yeah. Left to right. Yep.
disappear.
It's a left to right subtraction. Okay. So these two have to go away, and then I just get a left, and I get a right, and I get an up. A left and a right and an up. Except I don't see that as any of my choice. I still get. Okay, wait. Sorry. I get a left. I get a right. I get an up, but I don't get an up left. Okay, so I think it's F. Wait. Yes, it is F. Yeah, it's gotta be F. Okay. Man. All right, we got 10 left. 7 minutes. So we got to go kind of quick now. Or I wonder if there's a penalty for guessing. I didn't check that. Bro, what is this? All right, 232, 422. No. I don't know. I'm gonna go next. I'm gonna skip this one.
I think it's a F.
Okay.
Because if the dots are overlapping, instead the dot stays.
Yes,
If
yeah,
the
I was seeing that.
lines Don't overlap, then it stays.
Yes. I agree.
So on-
Yeah, I was seeing that. The
on
dots and the lines are
the-
behaving differently. Yeah, okay. Okay. Rotates clockwise, opens up, and then closes. Okay, open, close, medium, close, medium, and then it should be fully open to the left. So I think it's A. Okay. This is another overlap question, isn't it? Yeah, okay, whatever. Okay, so up. Man, this is challenging my spatial reasoning. It's kind of like a V, I guess. tempted by A.
I think
A.
it's. I want to say it's A. It looks like
Yeah.
it'd be A.
I agree. One sec, Pineapple. We got 5 minutes left on this.
Yeah, we gotta lock in.
We gotta lock in. Fuck. The left-right dude is messing with me, dude. Oh, alright, I'm gonna skip. I don't know this one. Let's see here. Oh, is this one of these? Okay. If the dots overlap, they make a box. The boxes persist. And the dots persist. Okay, I think that's what it is. Dots overlap, they make a box. If they're different, they clear. And then otherwise they stay the same. So this should make a box on the left. A box on the right. What happens when we have box and box though? Ooh, fuck. I don't know what box and box does. I'm gonna guess they clear. Or maybe maybe they turn to a dot. I think if two shapes overlap, they turn to the opposite shape. So I think this is a box on the left, a box on the right, and then a dot on the left and a dot on the right.
Yeah, I feel like
Yeah,
it'd be E.
I think it's E. Wow, that's a fun one. Oh, dude, no. Dude, what the fuck is this? Dude, no. Oh, man. Oh, wait. Oh, if they overlap, they clear. That's it. Okay, fine. Okay, so it should be clear here and clear on the left corner. That's either A or D. But I need the middle to persist, so it's gotta be D. Alright, running out of time. We got 3 left. Alright, same thing. Except, if they don't match, they're gone. If they do match, they switch. And then oh, but now there's like box and circle. Matching turns to nothing as well, I think. Oh wait, no, if they match, oh man. If they match, they switch. Okay. Okay. I think there's gonna be no, this turned into a box though. Fuck. What? How does this turn to a box, but then this turns to a box and a dot? Alright, skipping. Can't get this. Alright, add...
In response to Pineapple's request.
Yes, what's up?
You need to work on your basic English first. Before you start asking about essays. You aren't at that level.
Yeah, listen to Sensation. He'll figure it. 1 sec. Let's lock in. We got a minute left. I don't know if we'll know the correct answer. I'm trying to take this test. It'll tell us the score at the end, I'm sure. I'm kind of flailing now though. I don't know how to do these. This is getting too hard for me. This is probably the genius level stuff I can't do.
It's binary. Look at it.
Yeah. Well, let me see.
It's more rotational stuff.
Is it?
It's just binary. Left and right is 1 and 0. Black and white is 1 and 0. And then it's rotating around a central core.
Yeah, we got like tops and lefts in though. Is it rotating from here?
It's rotating. Although there's weird additions coming out of nowhere as well.
Right? So yeah, that's what I'm saying. Yeah. No, this is
swaps. No, wait. There's swaps. There's bit flips.
Yeah.
Never mind.
Okay, what is it? I think we...
This is just fucking hieroglyphics 101.
This is so weird. Okay, we're just gonna finish. I couldn't get these last ones. IQ 128. Okay. So close.
I'll take it.
So Mensa is apparently you need to be 2 standard deviations above. We were almost Mensa. Almost Mensa. Those last couple ones, man.
I don't know if I ever mentioned this, but they made me take an IQ test in year 7.
Okay.
It came out at 159, was it?
Damn, you're smart, dude.
I bet you any money that wouldn't be true now.
So I don't think this is a standard like IQ number because look, it kind of tops out at 145. So I think the Mensa IQ, I think percentile is the more important thing. So 97th percentile. Not bad. So the collective intelligence here on this stream is the top 3% of the world. I think that's pretty cool.
I think we could have been higher if you didn't keep skipping them.
Okay, my bad. Well,
there were like 3. I was almost there.
You were almost there? Yeah.
You were like, skip.
Yeah.
Also, I would have skewed the results if I'd joined in. It would have been much lower.
Yeah.
How did we manage 60?
Yeah, you're right. So Breskles is right. If I'd probably waited a little bit more for some of them. We were just running out of time, and I wanted to see ones if I could see patterns. Those last 5, man, are just hard. I would like to see them
the ones with the
again.
line straight down the middle was easy for me because it was just binary representation.
You know what I think would be cool? I'm gonna shout out Zach. Zach should do this for his stream. I want to see Zach do it. But like not look at the answers. I guess, but yeah, and he does stuff where he screen shares. Yeah, here's an idea. Yeah, so top 3%. I'll take it. Okay, here. Let's go tell Zach to go do this. I'm gonna go tell him in his Discord. What was it? It was under his streamiversary ideas? Yeah. And then how long was this? It was 25 minutes.
Yeah, 35 questions, 25 minutes.
Yeah. Damn. I mean, you definitely helped me, Breskles, with, like, I can't claim that's all mine. And neither can you claim that that's as low as you are, because, yeah, you probably would have gotten more than I would have gotten. And I think I would have gotten less than you would have gotten, because you definitely helped me identify some like, once I saw the pattern, I was like, okay, cool, now I know it. I feel like this is why if I took the test again, I would do infinitely better, because I already know it's like either like rotations or subtractions or other types of things.
Well, that's
I do
one of the
really well with like arbitrary like patterns like that. I don't really know.
It's
why,
cool.
but I, like,
No. I mean, that is a sign of intelligence, man. Pattern recognition is totally
like symmetries, and I'm really good at isolating like what would be independent, like where it, a shape starts, like the rotation, and you're adding one. I was like, okay, well, we're adding one, but we're also kind of rotating by 90. We're adding one to the pattern, and we're rotating by a 90 degree.
Yeah. For the results to be valid as possible, make sure you're sitting in a room that's properly ventilated. Sensation. I don't think this would apply to you, dude. Right? The ventilation is
doesn't
the issue
apply to me either. You're the only
it's
one
not properly ventilated. What's up, Sensation? What's up?
Quite a lot of these tests are contingent upon working memory as well. Which can be a problem. So that's why they're not particularly useful to determine someone's functionality. There are plenty of people who are literal hyper geniuses.
Right, but they just don't have the functional memory
working
for things.
memory. And there are
or even
there are people like me who can't talk. Period.
You can't
And
talk. You just trip on your words.
There
a
are
little
people
bit.
like me who can't talk.
Oh, who can't talk. Oh, okay, gotcha.
Period. And
Period.
you would assume they were stupid.
Yeah.
yeah, that's for like with an IQ test like this. Like I had a teacher in high school. He's my programming teacher, and super smart guy, but like he has graphic dyslexia, and so like a test like this, where it's like, yeah, recognize a bunch of patterns and a bunch of shapes in a 3x3 grid would be almost impossible, you know. And it's like it's not a measure of his intelligence necessarily. It's just a literal like visual problem, right? He doesn't see that well. He has
Yeah.
a graphic dyslexia, so he couldn't perform on a test like this.
Crazy, dude. This was super fun. I enjoyed this. Did you guys have fun? I had fun doing it. I thought it was super dope. I thought I totally sent this email though. What the hell?
Where are you going anyway? Anywhere nice?
I'm going to Michigan.
What's in Michigan?
There's a festival out there. Little music festival.
But is it Burning Man? It's not Burning Man.
No, Burning
Man's
Man's in August. Burning Man's in August.
Will there be lots of paint offing?
There'll be lots of things going on for sure. Okay, there you go.
Lots of really roided up fuckers like on more roids going.
Oh yeah! No, it'll be fun. I wasn't actually planning on going to this event, this festival, but this one artist chick that I kind of helped out a lot throughout her whole DJ career. Like I did her logo, I did all her visuals, I did a lot of stuff for her. She kind of just called me a couple weeks ago and she said, "Hey, I have like an extra artist wristband for this event." And like artist wristbands are super nice because you can go anywhere in the festival. It's like all access whatever, and there's like free drinks and free massages and I was like, "Oh, okay." She's like, "You really helped me, so I was thinking I could repay it and give you my extra band." I was like, "Damn, okay, cool. I wasn't planning on going to this, but I'll take it." It's a kind of a fun once in a lifetime thing to be all access at what is a really cool festival. I've been to this festival 3 times before as just like GA, and honestly like GA has the most fun. Backstage stuff is kind of like a bunch of like hoity-toity, snooty, pretentious people being like, "Oh yeah, well, you know, he didn't transition that song exactly correctly and I would have done it this way." But it is, I can't deny the amenities are nice to be able to go backstage. It's like free showers and stuff. Super nice.
The opposite of Burning Man.
It is very much, yeah. Burning Man doesn't have any sort of like VIP. It's like it's very heavily frowned upon if you start like gatekeeping things at Burning Man due to like being on a list or being on a whatever. They get really upset at that. It's like it's very much against the ethos. Yeah. Down to Skate. What festival? Electric Forest? Yeah, Electric Forest. It's a fun one. You ever been down to Skate? You been to Electric Forest? I went in, I want to say 2022, 2023, and 2024. I didn't go last year. And I guess, yeah, I'm going to last minute send it to this year. Although I'm only going up for some of the days. What's up, Sensation? What's up? What are you
So I keep talking over you.
No. I keep talking just because I'm loud. What's up?
I wish I could drive, because then I'd love to like go to Burning Man with an RV.
Yeah. What, you can't drive? You don't have a license?
Can't drive.
Can't legally drive? Or like you can't physically drive?
We noticed there was a problem when I was about 12 and I kept crashing into parked vehicles.
Oh no.
So
oh no.
Can't drive in the literal sense.
That's too funny.
At the age of 20, I had a disabled bus pass, which are notorious to get hold of. Notoriously difficult to get hold of. So that proves that point.
Yeah. Well, you know, I can drive for you, at least, Sensation. You know?
Right, I'll get the Winnebago and fill it full of water, and then you can drive.
Yeah, exactly. Fill it full of water and I'll drive it for you. Yeah, I got you, dude.
How would you do that? What kind of barrels could you use? The big blue ones.
You can get refills at Burning Man if you pay for services. You can get refill stuff.
How could you trust the water though? That's the question.
I mean, it's that or whatever. It's you can also bring enough water. Like you maybe couldn't bring enough water to take showers and stuff, but I bring plenty of water to just drink and stay hydrated. Also, it's like open bar at Burning Man. Like everything's free. So if you really were thirsty, you could just go to like any of the thousands of open bars that are happening and just dehydrate yourself more.
But it's a desert. I couldn't go without a shower. I'd fucking die.
Yeah, no. Showers, you have to take like a bird bath shower. So in my case, it's like you take like some water and you just kind of like dip it over yourself while you're like in a bucket. Let's see. Down to Skate says, the cops have been pulling over car. Yeah, I did see that on the Facebook groups. Down to Skate. I appreciate the heads up. Yeah. So heading in. Yeah, the cops are they're pretty much dickheads at any sort of festival because they know they're shooting like fish out of a barrel. Like if you pull over one of these cars and it's going to or shooting fish in a barrel. Is that what?
Fish in a barrel. Yeah.
Okay. Yeah. It's like shooting fish in a barrel. Because yeah, if you pull any of these cars over, you're gonna find something you could bust them with. Like, yeah. But I appreciate.
That fascinates me.
What fascinates you about it? Yeah.
Oh, because you wouldn't get away with that in this country. They're like, "What are you pulling me over for?" And
they'll just make some bullshit excuse. Yeah, no.
Yeah, and then we turn around and say, "Well, you can fuck off then, because you don't have a reasonable reason. You don't have a reasonable excuse to pull me over."
Yeah, I mean,
I'm driving. Go fuck yourself.
Yeah, a lot of times, Down to Skate's talking about the cops pulling people over. It's because people are speeding, or like they're on their phone, or maybe like their registration isn't up to date, or their tags aren't like whatever. The cops do find some legitimate reason to pull you over, but then they unfortunately kind of bully and pressure and like psych people out to consent to searches. That's the problem. And people don't know their rights, and they don't know you can say, no, I do not consent to the car being searched, because in their mind they're like, oh well, whatever, just the cop's not going to find anything. Like, rather than make it look like I'm guilty and say you can't search my car, I'm just going to let him search my car. And then the cops do find stuff, and then you have a felony.
Emotional, damn it.
So, yeah. People just don't know their rights. Cops, unfortunately, look at this as a moneymaker, because these are non-violent people, dude. It's a bunch of hippies just trying to go to a music festival. Like, let them eat their mushrooms, dude. Who cares? They're not going to do shit. But the cops see it as a way to, like, hit quota and stuff. So, unfortunately, yeah, you're right, Down to Skate. They are going to be doing that. I am luckily going up Friday, like, afternoon. So I'm not going up when everyone else is already there. They've been going up today. They'll be going up tomorrow. By Friday, not many people are going up to the event, so I should hopefully be a little bit more conspicuous about my intentions. But yeah, no, I appreciate Down to Skate, all the warnings. That's cool you found our stream and you're just like, oh, Electric Forest. Oh, it's right down the road from you. Very cool. My grandfather used to get paid to dance with the girls there when it was called the Jack and Jill Ranch. Now it's just called the Double J Ranch. Yeah, it is called the Double J Ranch. Oh, that's funny. I didn't know that Double J stands for Jack and Jill. It's a very cool venue, Down to Skate. I hope you go sometime, man. It's awesome. It's one of my favorite commercial festivals for sure. Sensation, we gotta go do Glastonbury. You wanna go do Glasto?
Honestly, I don't think I'd tolerate a festival in this country.
Oh, okay.
I am well versed in all of its people and all of its subtypes.
And he says, I hate them all equally.
Yeah.
It's okay. We'll get you to do fun things. Breasticles, you want to do this? I'll go over time, if you want to. You want to do this one? You did submit it. It's cool.
Yeah, sure. It shouldn't take too long.
All right, let's fucking do it, dude. All right. Find the Fourier series of the following. F of x is equal to -1 from negative pi to 0, and it's equal to 1 from 0 to pi. And what is this p is equal to pi thing? What is this? What does
Oh,
this mean?
so here, let me send you the formula for the Fourier series. P is the interval.
Oh, okay,
so it's
p
on
is the interval.
from negative pi to pi.
Yeah, this is going to be an infinite series, right? Because you're basically creating a square wave, no?
Yeah, that's what we're doing.
Yeah, this is cool. Sensation, you know about this. This is kind of like signal analysis, right?
Intervals.
Well, no. So you know, like if you wanted to create, I guess this is what it looks like. You know, like a square wave looks like this, yeah.
Yeah.
In terms of like standard like signals and stuff, yeah. This is basically a square wave, because if you were to repeat this this pattern, let's see if I can repeat it. Oh no, I fucked up. Yeah, there. If you were to repeat the pattern, it basically looks like a square wave. And the cool thing here is that you can represent something that's really rigid and blocky, right, as a summation of a bunch of oscillating waves. Like, and if you add them up in the right way, you can get this to kind of look like a square wave. Let me show you like another picture of this. See, square.
Fourier transforms.
Yeah, so Fourier transforms are kind of a mathematical trick for showing how to make shapes out of waves. But here we go. This is a beautiful example. I like this. This is very cool.
I thought it was the other way around, where you take a load of overlapping sine waves.
You do. Yeah.
And
So
try and pluck one out.
No, you don't try. You can if you're trying to analyze things. But the cooler thing is here. So if you have, again, a bunch of sine waves, you see how like there's a red curve and then there's a yellow one and a blue one and a brown one or whatever. If you like put these curves like on top of each other, actually I really think what's happening is the rainbow progression is showing what happens as you add higher frequency waves on top of this. But anyways, as you add oscillating waves, here, let me copy this picture. Sorry, one sec. I'll just make this more. I'll make this have a little bit more sense, and then we'll do the math. I love showing the conceptual reasons for why this works. Okay, so if, for instance, you were trying to describe this square wave, whatever, right here. If you're like trying to describe this, you could start out, and let's say it's from the interval from 0 to 2L. Like you're just trying to do it from here to here. You could start out with a low frequency wave that just does this, okay? Do you see how this gets like kind of close to what this looks like? Yeah. So then what you could do is you could say, okay, on top of that, I'm going to put this wave, okay? And I'm going to put it in such a way that, again, it kind of, when this orange wave gets added to the red one, it's going to look something like this. You do it in such a way that on the edges, it's like it's adding the most. Yeah.
I think you should change the scaling of the orange one just a bit.
Yeah, right? What should I do? I want to show that it acts here.
Yeah,
the red is the carrier one.
I want to say 3 humps in this case, because technically when we produce a sine wave, we use the first, third, fifth, seventh, and so on, all the odd harmonics.
Okay.
But we don't use any of the even harmonics.
Got it. Okay.
So whenever n is even.
So let me see.
So it would look like.
Would it look like this?
It would be like sine of 3x.
I think that's this, right? Is that sine of 3x? This is sine of x for sure.
So.
Yeah, I think so.
Seems correct.
Seems correct. But then you would want to phase shift this though, right? Because you want the peak to add to here to give you this thing. And then it's kind of hard, I guess, there should be a good graphic for this. But basically what happens is...
I don't think there would be any phase shifting.
Maybe not. Oh, right. All right, because it's 0 here, but then it's maximum, like, up here. Okay, I think I see what happens. Yes, you are right, actually, Breskles. Because what happens is as you increase the frequency, you then increase like the location of that first hump so that it gets closer and closer to the edge.
Yeah.
Okay, cool. So anyways, they're all waves that like start here, but when they get put on top of this one, yeah, Sensation, like the carrier wave, they add up in a way that eventually ends up looking like a square. What's up, Pinhead?
See, that's one thing I never truly comprehended. This is probably completely getting off topic now because
No, it's okay. What's
talking
up?
analog versus digital. But you have a frequency. Let's just say 104.7 Minster FM.
Sure.
And someone's it's a real radio station, don't ask.
Okay.
And somebody talks in a microphone and it goes across this frequency, so then you're adding a vocal waveform to an established frequency, and that's the bit that always confused the shit out of me.
Yeah, and so this is added in two different ways, right? So you have AM radio, which is amplitude modulated, and you have FM radio, which is frequency modulated.
Or FUM.
FUM, yeah, M or FUM. And so, what that
do you not know that?
I don't.
I'm
know
going
what.
to show you that.
All right, show it to me. But what that means is you are totally right. So if you had a radio station here and whatever, it's beaming out waves, and it's at let's say like 104 megahertz or something. I don't know, right? This is like the base carrier frequency. Within that, you can modulate. Modulate means you can modify it a bit. You can do some shit to it, and so you can do what's called amplitude modulation, which means that like within this wave, you have certain points where it's higher in amplitude. Okay? And those little bits of higher in amplitude get filtered out from the base frequency to then form the frequency that's being carried on top of it, and that is then the human voice you're hearing, I think. And then I guess the other way is to have this be modulated in frequency. So instead of the wave being constant like this, you have points where the wave is like a little bit more compressed in terms of frequency or in terms of time, and places where it's like more spread out, and that can then get subtracted from what the base frequency should be, and that also produces a carrier frequency you can listen to, I think. Yes, also we have a calendar. Sensation, send him the calendar. Pinhead, we will not be live any other time this week, but we have a lot of other friends that will be. Okay, so I'm gonna go back to what Breskle's doing, but this is cool. This is cool. I'm glad you asked this, Sensations. It's kind of fun.
Just quickly click on that link at that time index.
Okay. Oh, Mr. Mosby. This is...
No, that time index.
I'm sorry. Why don't we just relax and turn on the radio? Would you like am or film?
Mr. Mosby. Dude, okay, isn't she married to Macaulay Culkin?
I don't know.
I'm pretty sure she is. Okay. Just a little tidbit. Okay. All right. So, yeah, we're trying to produce, again, a square wave using a Fourier series. Fourier series is just adding up a bunch of sine waves. And let's see what the formula is. It's this. Okay. So f of x is equal to a naught over 2, which is equal to 1 over rho integral from negative 1 over p integral from negative p to p f of x dx. And then it's plus the infinite series here of an cosine nx over p plus bn sine nx over p. Cool.
Yep. And then we're gonna first, just to make it easier,
Are we going to split it into two different areas?
Well, so kind of. What we don't need to necessarily consider the an and the a naught, because if we look at our function is an odd function, right?
Okay.
It's symmetric about the origin.
I agree.
So we can take a look and we can say, okay, f of x is going to be odd, right? So for our a naught, right, our constant there is going to be the integral from negative p to p. Well, the integral of that's just going to be 0.
Good. Yeah.
Same
okay.
thing with our an. So
Got
we don't
you,
need to consider our cosine part of that, right? The easy way to remember it is if your function is going to be odd, then you use a sine series. If your function is even, we're going to use a cosine series.
And if the function was even, I would have to use my a naught then, right?
Yeah.
Okay, so we can get rid of this one, and then we can also get rid of. Sorry, if f of x is odd, an odd times an even is an is wait,
This is
now,
also
is
an odd, yes.
is also an odd, and integrating an odd is okay. And then I gotta remember which one is even. I think sine is even. No, cosine's even.
So
this one goes
cosine
away, right?
is even, yeah. So our an disappears. An easy way
Yeah.
to remember it, cosine's even. So if your function's even, you use cosine.
Yeah.
Sine is odd. So if your function is sine, you use, or if your function's odd, you use sine.
Yeah. Okay.
And that only works on the interval of negative p to p.
Negative p to p, right? Because this is
If you're
symmetric.
doing like, yeah, if you're doing like the series on like 0 to L, you would have to use a full Fourier series, including both cosine and sine terms.
Okay. Okay, so we just need b of n then, right?
Mm-hmm.
So is that going to be 1 over pi? And so b of n is equal to 1 over pi, negative pi to pi.
Yeah, and we can also make our life easier since it's even. We can call it 2 over pi and then 0 to pi.
Oh. Yes, I got you. Because I was going to say we got to split it from negative pi to 0 and 0 to pi. But yes, I get it. Because sine of negative x is equal to negative sine of x, then going from like negative pi to 0 of sine of negative x is the same thing as going from like 0 to pi of sine of x. Yeah. Cool. Okay, I think I get that. Sorry, if this is like f of x.
Yeah, I was gonna say. It's,
Yeah, sorry, there has to be an f of x in there as well. Right, because this would be negative 1, and then this would be... sorry, this is... whatever. I get it. I see how it works. It's cool.
Yeah.
Okay, so this is 2 over pi, and this is going to be 0 to pi. And then this is just going to be 1. And then it's sine of n pi x over pi dx. Yeah?
Yep.
Oh, cool. Pi's cancel. So then I'm left with 1 over... So 2 over pi n negative cosine of nx evaluated from 0 to pi.
Yep.
Cool. And then cosine of pi is negative 1, so that's going to be positive 1. And then minus 1 is going to be plus 1, so that's 2, I think. So this is 2 pi n times 2. So that's equal to 4 pi over n? I think so. Right. Cosine of pi x is negative 1, and then it's a negative of that, so it's positive 1.
But it's cosine of n pi.
Oh, we forgot the
So
n.
what it actually becomes is the cosine of n pi will become a negative 1 to the n. Because as you choose values of n, it'll go 1, negative 1, 1, negative 1,
Okay.
negative 1.
It's all right. So it's cosine, negative cosine of n pi minus, I got it, minus cosine of 0, but cosine of, or plus cosine of 0, but this is 1. Yeah. And then this is going to oscillate between negative 1 and 1.
Yeah. So and then we can pull out the negative as well. It makes it look a bit cleaner.
Okay. So negative 2 pi over n. And then you want to do 1 minus cosine of n pi? Is that kind of what you wanted?
Sorry, wait, hold up. Let me look back at my notes.
It's like, hold on. Down a skate says digital root is summing multiple digits until you wind up with a single digit result. Example 10 would be 1 plus 0 is equal to 1. So the digital root of 1, 0 would be 1. Oh. Okay. What would it be for like, I don't know, like 29? Right? 2 plus 9 is 11. How does that work? Digital root is... So you wind up with a single digit. Okay. What would the digital root of 29 be down a skate? Would it be 1? Oh, that's cool. That's a cool little thing. I have to read more into that Downscape. I've never heard of digital roots. That's fun though. Oh, okay. Oh, I see. Oh, you keep going. Oh. Got you. Oh, that's so cool. I see. Okay, so here's actually kind of my next question. If you had... let's come up with a ridiculous number. Let's say, for instance, you had 8888. Okay? That would be equal to 32. But then the digital root of that is 5. Okay. I'm wondering if this thing is then greater than 10, like what happens? Yeah, what if, for instance, you had 8, 8, 8, 8, 8, 8, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Why would that work? That's 80. No, that would just be 8. Fuck. I'm trying to think like how big of a number you would need to have to do the digital root again. Okay, let's see. For this one, for the Fourier series.
Then ignore that part I said about factoring out the negative.
Don't factor out the negative.
Yeah, I factored it out like in the very beginning when I was doing the work, and then put it back in.
Okay.
So you can just leave it there and then write the 1 minus the -1 to the n.
Oh, I see. This is -1 to the n. Got you. Okay.
Yeah.
Okay, so 1 minus -1 to the n. Okay, cool.
Okay, and then we can just plug that back into our Fourier series.
Into our Fourier series here. So f of x. Okay, so f of x is now equal to the sum from n equals 1 to infinity of 2 pi over n, 1 minus -1 to the n. And then that's sine of nx over pi.
It should just be sine of nx, because it's going to be sine of n pi x divided by...
Oh, so there's not a pi here?
I have to write a pi in there.
Okay. N pi x over
It should
pi.
be n pi x over p. Yeah, so
Okay, so we're going to leave it like that.
pi's would cancel and it becomes nx.
Okay. Okay, and then so when subtracted from 888, you get 8883, which is 27, which would be 9. Oh, I see what you're saying. Whenever you subtract whenever you subtract the digital root, you always the new thing that's digital root is always 9. That's really cool, actually. I see down to skate. That's really fun, and it works for any number greater than 9. That's why, dude. Where do you come up with that? That's fucking cool. That's some cool number theory stuff. I get it now. Is this? Can we simplify this, Presticles? I feel like we can.
Yeah, you could pull the 2 pi out front, and
Yeah.
then you could rewrite your index to be n equals 1, 3, 5, 7, 9.
Oh, because
getting rid of the 1
well,
minus. It's from the 1 minus.
oh, because if this is even,
yeah,
got you.
becomes 0. ...
Right, got you. And then this is so 1 over n, 1 minus -1 to the n. Sine of nx.
You don't even need to write to the 1 minus 1 to the n anymore.
Oh yeah, you're right, because this will.
We've already clarified that it's just odd terms.
Okay, and if it's odd, it'll be 2, right? So this would be a 2.
Yeah.
So this would end up being a 4 pi.
Mm.
Okay, so it's 4 pi sine of nx over n. Oh, very cool. Yeah?
That is that's my favorite
Nice.
Fourier series.
That's so fun, dude. That's a really fun Fourier series.
Actually, I wrote about it in my PDU paper. Pretty interesting.
Well done!
Especially when you have an attenuation constant that's based on frequency. It gets
Mhm.
cooler.
That was a cool one. Here, let me maybe mark that we did that one. That was cool. Mark current. Mark done.
See, as I was going to say before, you like, do you know this? And it's like, I'm predominantly not going to know academic stuff. It's simply a case of, here is a NES, it is broken, and I'll sit there with a fucking electric probe to figure out which one.
Pokey, pokey.
It's all practical, and I have no academic background, which is what this is all about.
No formal academic background. See, you still have experience with it, though, Sensation. You just don't have, like, the formal class behind it. But you still have experience with it.
It's really weird, like, in... how can I put this? So I know how to do stuff, but then it's like...
Yeah.
But then it's like, when it comes to academics, we're all the way back to year 7 stuff. And it's like, this is weird.
I get it. Yeah. You know what would be the same thing? Is if, let's say you just watched a bunch of anime, and that's how you learn Japanese, right? And you were conversational. You were able to, talk with people and, like, figure out, like, hey, where's the restaurant? When are we meeting up? Blah, blah, blah. But then someone in Japan said, okay, I need you to take, like, a formal Japanese language test. You'd probably fail.
Yeah.
Right? Because you don't know, like, the proper foundational knowledge behind the skill. But functionally, you already know how to do it.
I can have a conversation.
Right. But if you were given, like, a test on it, like a former, like a grammatical test,
for shit.
Exactly. It's the same thing, actually. Me with piano, for instance, I can't, like, read sheet music and play piano, but I can jam. So, like, functionally, I can play piano. But if you give me, like, sheet music, I know what the notes are. I just can't compute it to my hands quick enough. If it's cello, I can sight read cello music. I can't sight read piano. And even if I looked at it in practice, like, it would just take too long. But if you give me, like, a riff and you're like, hey, play along to this, I'm like, ooh, I can do that. So I think it's kind of the same thing that you're describing with math and science and stuff, and that's still cool. I think it still counts. I don't think you're any less of a person just because you don't know the functional stuff.
Well, I don't know if I feel like less of a person. I feel less educated.
Sure. Less formally educated. That's okay, though.
Because someone will come up with someone will ask me a simple question. I'll just be like, I have no idea what you're asking.
Downesgate says, I'm a retired senior lab tech. I goofed around on pencil and paper between titrations and analysis all the time and found all kinds of interesting things. That's super dope. Yeah, that's super cool. That whole what was it called? The digital root thing you talked about? Yeah, let me show it to the stream real quick. It's actually a pretty cool thing. So they were saying the digital root is when you add all the digits of a number, and then from those digits you add those digits together, and you get a number that's less than 10. So here, Sensation, give me a number between, I don't know, 1 and 5,000. I don't care.
1 and 5,000?
Yeah.
3,592.
Oh, I like that. Good. Okay, cool. 3,592. Okay, so this is a number. Let's calculate what the digital root of this would be. So we're going to add up what all the digits are. So 3 plus 5 is 8. 8 plus 9 is 17. 17 plus 2 is 19. Okay? And then from these, I'm going to add it up, right? And this is going to give me 10. But you keep doing this until you get to a single number. So then 1 plus 0 finally gets you 1. Do you see how that works? Right, this was 3 plus 5 plus 9 plus 2. And then this is 1 plus 9. And then this is 1 plus 0. And then finally you get to 1.
I don't get it. It just looks like some weird truncation.
Yeah, so you're adding the digits of the number together to get a new number, right? If you added 3 plus 5 plus 9 plus 2, you would get 19. But this is not a single number. It's not a single digit yet. So you still have to add these digits together. So 1 plus 9 gets you 10. You're getting closer. 10 is still not a single digit. But then 1 plus 0 is equal to 1. You see that? It's a cool little like puzzle. Okay, why? Okay, because then this is the cool thing Down to Skate showing, is that if I take any number and I subtract its digital root, the new number's digital root will always be 9. So if I do 3592 and I minus 1, what do I get now for my number?
What? 3591.
Perfect, good, okay. What's the digital root of this number?
16.
So 3 plus 5 is 8, and 8 plus 9 is 17, plus 1 is,
18.
yeah, 18, good. Okay, but 18 isn't a single number. What's the digital root of that?
1 plus 9.
9, yeah, cool. Okay, let's try this again. Give me a number, give me another 4-digit number. I don't care, just come up with a random.
Is 3591 a multiple of 9 then?
No, I don't think so. I don't think this has anything to do with multiples.
Well, the reason I ask is because in the 9 times table, everything always adds up to 9 or multiples of 9.
Oh, you're right. It is a multiple of 9. Yeah, it's 399. That's actually kind of cool.
If you go, yeah, that's the only time I've ever noticed where you add numbers together and it.
That's pretty cool.
It's either 9, 18, or 27, and then they're multiples of 9 because it's part of the 9 times table.
Yeah. So pick another 4-digit number. I don't care what it is. Let's just check it out.
4251.
4251. Okay. So let's see what the digital root of that would be. So 4 plus 2, right? 6. 5. It's 12. Good. Cool. But that's not a single number. So what's the digital number? What's the digital root of that?
3.
Good. Okay. Now let's do 4251 minus 3. What does that get you?
4248.
Good. All right. What's the digital root of that going to be?
4, 8, 10, 18.
18. And then what's the digital root of 18?
9.
Do you see how it's 9 again?
Right, so it's basically decimal, n minus 1.
Yeah,
it is a decimal.
Yeah, I googled it. It said that it's equivalent to the number mod 9, and so if it outputs 9, then I guess technically it's 0, but it tells you the number mod 9.
Tells you the number mod 9. That's pretty cool.
Yeah,
man.
the next whole integer minus 1.
Oh, that makes sense. That makes sense actually now. Okay.
Because then, like, if you did
because you're making it mod 9 then. You're making it mod 9 basically, or you're making it divisible by 9, right? I think. Yeah.
Although mod 9 of 18 would be 2 though.
No, because so modulus means what's the remainder left over when you divide by 9. So 18 divided by 9 is 2, but the remainder is 0.
Wait, hang on a minute. What am I getting confused by? Because whenever you use mod, it gives you. I know, because it always gives you the remainder when you use mod function.
Yes. Yeah. Exactly. So, for instance, if you did like 16 mod 3, well, 3 doesn't go evenly into 16, but it goes into 15, and so what's left over is 1.
What's the other function where it just gives you the not remainder?
Oh, I actually don't know what that is.
No, I can't remember.
It's probably like floor.
In
floor of division.
Functions.
Yeah, I think it's just like floor. Floor of like 16 divided by 3.
Well, no, because floor and ceiling are other ones as well. But,
right.
No,
well, because 16 divided by 3 would give you a fraction, or it would give you like some decimal part, and you just axe the, goodbye. Yeah. That's very cool. This is like a mod 9 thing. What are these little pictures you sent me, Breasticles? These look fun.
Oh, those are the same wave, but that's when you're doing a square wave, propagating through a
was this your report? You said you did this. You did this for a report.
This was part of it. This was part of the 32 pages I wrote for PDE.
Holy shit, dude! Wait, is this for the class you're taking right now over the summer, or something different?
No, this was for when I took PDE. I had to write a paper on the actual like applications of some of the stuff we were learning in PDE. So this part was on the wave equation. So what that is in the bottom it says TUC 885 400G is blue and FR4 is red.
Yeah.
Those are PCB materials, right? So as electric field propagates through that PCB, it has a frequency-based attenuation constant.
Okay.
So we get a slightly modified version of a square wave. And basically what that image is there to show is, in this case, because I couldn't find the specific attenuation constant for FR4 at 10,000 hertz, this is not a high frequency PCB material, while TUC 885 is a high frequency material. The blue is at a frequency of 10,000 gigahertz, or sorry, 10 gigahertz, and the red is at a frequency of 1 gigahertz. And the point of the image is to show that you can see that on the blue, it's not very zoomed in, and it looks weird because you'll see it overshoots at the edges.
Yeah, it does. Yeah.
That's called Gibbs phenomena. It just happens with square waves in the Fourier series. It overshoots at the edges. It's not like a physical thing necessarily. It's just what happens when we talk about Fourier series and square waves. But you can see it still has a kind of clear defining, -1 or 1, -1. And it slowly attenuates to have less signal. And as it attenuates, it starts to look more like a sine wave. And
Yeah, it looks more sine wave. Yeah.
And so the point was to show that if we're talking about really high frequency computing, like something, at 10,000 gigahertz, for example, we don't want to choose a PCB material like FR4, because you can see basically by the third hump, right? I guess the second valley, that material basically just becomes a sine wave.
Yeah, and so now I can no longer hold it.
We don't have a clear defined square wave. And so that's like a big thing in electromagnetic field theory for like engineers and like transmission lines and signal losses. Is a very common question would be to say, hey, we're sending a square wave through like a coax cable, and our input is a square wave and our output is a sine wave. Why is this the case?
Yeah.
And it's because of, in those equations, you see the, the negative alpha sub n to the z term. That exponential decay is based off frequencies. So at high frequencies, it basically just kills out the entire wave, and you just kind of get a sine wave.
Very cool. And this looks like kind of like almost like a senior thesis or something you did.
It probably was pretty close. He wanted it printed out on paper, and it was thick enough that I had to hand him a binder.
Yeah.
But yeah, that was the ending segment of it. The beginning segments were like the Laplace equation, and electromagnetics, and capacitors, and conformal mapping, and Maxwell's equations, and a fair share of other stuff.
Dude, super dope. Okay, cool. This was super fun. Appreciate all the questions. Let's close out the stream. I want to go to the gym. All right. Thank you everyone for coming to Actual Education Office Hours today. What's the game? No, Jim's very important. I appreciate everyone's questions today. Thank you, Down to Skate, for finding us and talking about the digital root stuff. That was cool. I appreciate it. Also, Breasticles with the Fourier transform. Everyone for contributing during the IQ test. Oh, yeah. That was really fun. But yeah, if you found us, make sure to go check out our calendar to see what events are coming up. I will have one more physics lecture tomorrow in the morning. Zach will be doing E&M in the afternoon. These are our other math and science streamers that stream on Twitch. So if you found us and you want to find some other cool people, please go ahead and check these guys out. And then Zach will be doing his trivia game on Friday. If you guys want to come by for that, that looks pretty fun. And then I will be out of town this weekend, but I will be back on Monday. So next Monday. So we'll resume things next Monday. And then I promise we'll do some fun recess games on Friday of next week. Because I know it's been a while since our chess tournament was like last weekend, or maybe last weekend. I think it was last weekend actually. But we're gonna do some more fun summer stuff. Doesn't have to all be math and science. Math and science is great too. All right. That being said, let's go find someone to go say hi to. Ta-ta. I want to go raid. Oh, someone's doing... Oh, I love Ask a Scientist Gaming. They're great. Go check them out. These people, they play video games. It looks like they're playing Sonic with a childhood communication professor. That's pretty cool. Go say hi to them. They're great. Okay. Enjoy the rest of your Wednesday. Enjoy the rest of the week. We'll see you tomorrow for physics. Otherwise, we'll see you Monday. Peace.